Well, this is bad news. Looks like that pipe just popped all the threads right off this hot water heater. This hot water heater. As you can see, looks like it might have been leaking for a while and those threads just wore plumb out. It popped them all off, spewed water everywhere. Now, gotta figure out how we're gonna get it fixed. All right, we will turn everything off. Desoldered this one so I could get to it. Let's see what kind of solutions we have for this. I don't know if this is part of the hot water heater or if this is a valve that screws in. That one looks like it screws onto the top of it. This one looks like it screws onto the top of it. And if that's the case, that one's sticking up quite a bit higher. So the question is, why? Is it just taller? Either way, this is very fragile. So I gotta figure out how to replace it. Talk to you later. All right, so here's what we decided to do. I don't want to connect these two different types of metal again. So I'm going to use these D-dielect unions. I'm just going to cut these off here and here. And I'll put these unions on and then we'll run the lines down that way. That way there is absolutely no question that it isn't going to do this again. Because it's obviously that is what's caused the problem here. Is this metal type had the copper pipe directly connected to it. And that is a big no-no because it causes the metal to deteriorate. So what we're going to do is we're just going to cut this off right here on both sides. There we go. And then the same over here. So I'll eliminate this huge giant footprint above here also, which is just completely unneeded. Here we go. All right. So that's done. Now we're going to take the sandpaper and I'm going to move this over a little bit where you can see a little better. And we're going to clean these up. Good, clean, shiny copper. To the other side. All right, so we've cut those. I'm going to wipe them, make sure they're nice and clean. And we're going to open up these. These should have a copper section that we wet on, and then a transformation section that transfers the metal with a rubber O-ring seal. So we're going to leave take this piece out and leave all of this for later. So these will sweat on like this. Yeah, all right, that's good. Oh, don't go on yet. We want to make sure we put the right greases. Let's get this one. Do the same thing. And we may have to sand those down just a tiny bit to get them to fit just right. Looks like it fits pretty good. Okay, so that, and then we can save for later. These out of the way. We just bought a little sweat kit here. Little soldering kit for doing water lines. I had some, but in all the moving, I probably had thrown it out. It's a pretty easy process. You use the sandpaper just to make sure that the lines are nice and clean, which we've already done. Then I usually just wipe them off to make sure they're good and clean here, that they're nice and smooth, there's no burrs. All right, then we're going to take this paste and just paste this all up. This will cause the solder to stick. Very important that you make sure every piece of it gets covered. Very liberally. And I always do both sides. And I always put a lot of extra in there just to make sure. And then we're going to push these on all the way in. That's good. We're going to make sure that's all in there. Brush a little bit around the edges here. And I'm sure those of you who do this all the time, it's super nice equipment. It gets super duper hot. And you know exactly what it takes to do this. I don't do it very often. So I tend to ensure that things like this that are going to cause problems later aren't problems for me by overdoing it a little bit. And that slips right on. And we'll do the same to this one. Fill in all the gaps so when it gets hot, it sucks that solder in. All right. And I'm going to leave this out just in case we need more. The trick is to solder on this side and not do any damage to this side, as this is the side that has to seal to this connector once we're done. So what we'll do is we'll take the torch, we'll heat them up. When they get hot, we'll just let the solder run into the seal. And then we'll heat the other one up and let the solder run into the seal here. It should not take a whole lot of solder to do these. They're fairly small connections. Pretty good. You can see the solder all the way around. Let's do this one. There it goes. Make sure we get it on both sides. Now we need to do a visual inspection to make sure that we got copper or solder all the way around the connection. One little spot without it, and this will leak like a water fountain spraying in here. The backside of this looks a little weak. I'm going to redo it just to make sure. And I'm double checking this one here. It looks good. There's a tiny spot right here, but I just see solder all the way on the inside, so I'm pretty sure that it's there. Now we wait for this to cool off and we connect everything else up. All right, these have a flow written on them. You have to follow the flow. So I'm going to put a little of this tape around here. Careful not to get into that flow protector there. All right, and then the other one, the blue, needs to flow in. So this is the cold water comes in, flows this way down into the hot water heater and then out that way. So one of the important things to remember about connecting a hot water heater is that you never hook the electrical up until the tank is full. Otherwise you could risk burning the elements in the tank out before you even turn your hot water heater on. So we will this one flows in this way, that one flows out that way, just double checking them all. This side needs some seal. The other side doesn't, as it has a rubber garment that seals. So we will tighten these down so that we don't have to worry about them. The cold and the hot lines, they have like a water hose, a rubber garment that seals right up to this. Same with this connecting to this piece here. So what we're going to do, I want to get 2 pair of pliers so I can this one has a rubber garment on it also, so I don't need to make it very tight, but I do need to make sure that it is at least tightened. So we're going to hold this side and turn that nut. There we go. And then we're going to hold this side and tighten this one as well. On both of these. Okay, and we hold this side and tighten this one. This is one of those Don't have the strength in that hand to turn that right the way I need to. And then we're going to check this one here. You don't want to over tighten them. You don't want to pull or stress the threads. These have rubber garments, so you don't need to over tighten them. They're like water hoses. You can get them tight without overdoing it. Now, these lines are pretty easy. We just want to form them in a way that doesn't have a lot of stress on them. And we're going to push them in place. So they seal good with very little stress, but now they have a little bit of flex in them so that when the water pressure bounces high or low, or this gets bumped around or moved or whatever, we don't end up with what we had before with those copper pipes directly connected to this stressing. These do not have to be super tight. Be careful not to over tighten them. As like I said, they have a rubber garment in them like a water hose. So you want them tight, but you don't want them overdone. All right. I think we'll do this one backwards. We'll start down here. Pretty good. And you could twist this a little bit if you needed to at this point. It looks like I got it right. I wanted to make sure I left enough room for the electrical to reach. All right, all the water lines are hooked back up. So we still have the electrical and we still have the emergency valve. We'll pick up an emergency drain hose here in a little bit. But this we can go ahead and fill the tanks. All right, so I have a shut-off valve here. I'm very fortunate this is how I turned it off when everything went wrong. I'm going to slowly open this up. You can hear water draining into the tank. That is my intention too. Just let water drain into the tank slowly. Sped it up a little bit here. Now what you want to do is you want to open a hot water line on like a sink or something so that the air can escape out here, fill the entire tank. Keeping in mind the size of your tank, and in my case, we have tons of water going in and nothing coming out because it's 40 gallons, so it's going to take a few minutes for 40 gallons to fill this tank. As it fills, we want to see if we have any leaks or anything. I don't see any at this point, but this is where you want to watch to make sure that nothing is leaking or coming out anywhere, because it will only get worse if it leaks now. So we'll give this a little while to fill up. All right, we're still filling. cold water is coming in through here, and I've turned it up a little bit. The tank is starting to get very heavy. It does have some flex in it. It still kind of worries me a little bit about the way these copper lines come out of the wall here, but I think it's okay as long as this isn't wobbling around a lot. Take a look at the electrical once we get to that point. This is a warning sticker that basically states, fill the tank, make sure everything is completely filled before you actually put the electrical on. So that's where this will be replacing that right there. And we'll leave this here for now until we're done so that we don't forget. All right. So it filled, and the sink started running, and I let all the air run out, and now it is shut off. The valve is wide open. And there are no leaks. This is good news. No leaks here. Any of the connections all the way up or any of the solder joints, everything looks like it's good and sealed. Now what we're going to do is hook up the electrical. Now we've confirmed that everything is on this sheet is done. Verify that all water lines are connected. They are. Verify cold water supply valve is open, which we have. And run hot water faucet in the house to ensure that water tank is completely full, which it is. So now what we'll do is we'll take a look at the screw out of this new one. I'll feel better. I'll put the meter on it myself. Let's see if I can do this without taking this other side of the panel off. I don't know why I would bother. There's just one screw. Let's just take it off. Alright, so this is the black line here. Wow, this is some tough wire to work with. Let's start with this one. I replaced both of these caps. You're not supposed to reuse these wire caps. And the reason being is that the inside threads sometimes they come loose and they no longer hold the way they're supposed to. So make sure that if you do this, you replace them with good new ones. Don't just assume that the old ones are okay. Okay, let's make sure those are in there really good, and they are. Let's put that back in there like that. Screw back on here. Get that down. All right. 2 hot lines and a ground. Everything's back in place. Everything's sealed and connected. Let's turn this puppy on. I show it's running at 4,800 watts. So using exactly the power it should be using to start heating that water up. We'll give it a little time and we'll come back and check it. All right, so here we are, we're all done. Hot water heater's shut off, the water's hot, everything's working just fine. We now have copper to regular metal transfer here that's appropriate. We have flexible hose instead of copper directly into the tank, which there was no flexibility, so any of this movement like this here was causing massive strain on the cables and the wires and everything. Obviously, there shouldn't be a whole lot of movement, but there also should be not a lack of the ability to move any at all. So everything's done here except the emergency drain-off valve, which I will pick one of those up. And it's just a little plastic drain that runs down into the pan. And everything else is functioning and working just as it should be. So hopefully this helps you. If you have any questions, please leave them in the comments below. I'll be glad to answer them. Thanks for watching.